In question 1, we're looking for the cotangent of angle B, which is the reciprocal of tangent. Tangent of angle B is opposite over adjacent. So cotangent of angle B would be the reciprocal. In the next question, we have a right triangle. AB is 5 and AC is 4. If you use the Pythagorean theorem, you should find that this side over here is 3, and it's asking which statement is not true. Well, from angle A, this would be adjacent and hypotenuse. So cosine of angle A is 4 over 5. So that answer choice is true. From angle A, here we have opposite and adjacent. So tangent would be 3 over 4. So that one's good as well. Sine of angle B, from angle B, here we have opposite and hypotenuse. So sine of angle B is 4 over 5. So that leaves tangent of angle B. From angle B, we have opposite and adjacent. Tangent of angle B would then be 4 over 3, not 5 over 3. So that's the answer choice that we're looking for. Okay, we're looking for which ratio is always equivalent to the sine of angle A. So since we do have two similar triangles here, they're similar to each other by AA, we do need to check out the sine from both of these similar triangles because the sine ratio will be the same for both of them. So the small triangle is triangle ABC and the big triangle is triangle ADE. So on the small triangle, we have opposite and hypotenuse. And on the big triangle, we also have opposite and hypotenuse because these are the 90-degree angles. So in the small triangle, sine of angle A would be BC over AB. And in the big triangle, sine of angle A would be DE over AD. DE over AD isn't an answer choice. BC over AB is an answer choice. In the next one, we have right triangle ABC. Angle B is 18. Now, it doesn't matter if you put angle B here or angle B here, you are going to get the exact same thing. It doesn't matter. It's just that your trig ratio might be different if you put the 18 over here. So based on where I put the 18, we know that AC is 8. So we have information about the opposite side, and we're finding the hypotenuse. So I'm going to use sine opposite over hypotenuse. If you put the 18 here, the only thing, actually, if you put the 18 here, let's redraw that really quickly so we can see. If you put the 18 here, then you would have adjacent and hypotenuse, so then it would change to cosine. So the trig ratio depends on where you put the focus angle. Based on where I put my focus angle in the triangle, that's going to be sine. So sine of the 18-degree angle equals to opposite over hypotenuse. From here, we can cross multiply. X times sine 18 equals to 8. Divide both sides by sine of 18 to get x by itself. And if you type into your calculator 8 divided by sine of 18, you should get approximately 25.9. Over here, we're told that we have similar triangles. AR is 13, HR is 12, and we're looking for the measurement of angle Y. Angle Y corresponds to angle R in the bigger triangle. So if I find the measurement of angle R, it should be the same thing as the measurement of angle Y because similar triangles have congruent corresponding angles. They also have proportional sides, so the trig ratios hold for similar triangles. So I'm going to find angle R, and I have adjacent and hypotenuse, so that's going to be cosine. So cosine of angle R equals to adjacent over hypotenuse. And then since I'm solving for the angle, I'm going to do inverse cosine of 12 over 13, and that's going to give me the angle that I'm looking for. And when I type this into my calculator to the nearest degree, I get approximately 23 degrees. Remember, if angle R is 23 degrees, angle Y is also 23 degrees because they're corresponding angles of the two similar triangles, which are congruent. Moving on to the next one. Sine and cosine are cofunctions, and that means that they're equal when their angles add to 90 degrees, when their angles are complementary. So in order to find where they're equal, I have to find where their angles are going to be complementary. So where 2x plus 7 plus 4x minus 7 is equal to 90. If I combine like terms, that is 6x equals to 90. Positive 7 and negative 7, they combine to 0. 90 divided by 6 is 15. And then it was asking for the larger angle. So I'm going to substitute back in. I'm going to do 2 times 15 plus 7 for the sine angle. And I'm going to do 4 times 15 minus 7 for the cosine angle. This one is 37 degrees. And this one is 53 degrees. So 53 degrees is the measure of the larger angle. In number 7, it does say to find your answer in simplest radical form. So although you do have a rectangle with the right triangles and you can use a trig ratio, that will not get you the exact value. You will have to round, and that resulted in a point off. What we can notice here, in order to get the exact value in simplest radical form, is that we have 30, 60, 90 triangles here. And when we have a 30, 60, 90 triangle, the sides are in the ratio 1 to radical 3 to 2. The side that we have is the biggest side because it's the hypotenuse across from the biggest angle. So we have the 2 part of the ratio. The best plan of attack here is to go to the smallest side. And then once you find the smallest side, you can find the middle biggest side. In order to get from the biggest side to the smallest side, that is a 2-to-1 ratio. So we're going to divide by 2 because we're going smaller. So 12 divided by 2 is 6. So the smallest side, which would be found across from the smallest angle, across from the 30-degree angle, is 6. Now all that's left to find is the middle biggest angle, a side across from the middle biggest angle. So now that we have the smallest side, which is the 1 part of the ratio, in order to get to the middle biggest side, we just have to multiply by radical 3. 6 times radical 3 is 6 radical 3. And since this is a rectangle, opposite sides are congruent. And now we just need to find the perimeter. 6 plus 6 is 12. 6 radical 3 plus 6 radical 3 is 12 radical 3. Be careful, these don't combine. They're not like terms. Oh, and that's the perimeter of this rectangle in simplest radical form. Okay, this one's one that we actually did in class, and they do ask a lot of Regents questions similar to this. We're finding angle theta, and the problem is that angle theta is inside a triangle that is not a right triangle. So a lot of people were trying to set up tangent of angle theta is equal to 60 over 75, but you can't do that. It's not going to result in the correct answer because that is not a right triangle and you can't use a trig ratio on it. So what we have to do is we have to think about where the right triangles are in our diagram so we can use the right triangles to make trig ratios. I have a right angle over here, so this triangle over here is a right triangle, and the whole big triangle is a right triangle. In the big triangle, we can find this angle. And in the small right triangle, we can find this angle. And then we can subtract the two to get angle theta, which is what we actually need. So once again, yellow minus red will leave us over with blue. And we can find yellow because it's an angle of the big right triangle. We can find red because it's an angle of the small right triangle. And once we have them, if we subtract, we'll be left over with the blue angle, which is what we're looking for. So first, I'm going to set up with the big right triangle, and I'm not going to use yellow for this whole thing. I just wanted to keep it consistent with the color I used here. So from the focus angle, which is the angle we're looking for, in the big triangle, we have opposite, which would be the whole side of the big right triangle since we're using the big right triangle. And 60 plus 12 is 72. And that's opposite. And we also have adjacent. So that would be tangent. And I'm just going to call this big angle angle x, just so we can name it something. Tangent of angle x is 72 opposite over adjacent. And from here, we can use inverse tangent to solve for the angle. I don't want to round early, so I'm just going to leave it like this now. I'm not going to even put it into my calculator yet. You can, but if you do, leave like 3, 4 decimal places. Okay, now let's do the trig ratio for the small right triangle. And I'm going to just call this one angle Y. Let me use a different color so you can see it. I'm going to call that angle Y. So we once again have opposite and adjacent. So tangent of angle Y is equal to 12. That's the side from the small right triangle. Over 75. That's also a side from the small right triangle. Inverse tangent, once again, find the angle. And as we spoke about before, we can do big minus small to get angle theta. So angle theta is going to be equal to angle x from the big right triangle, which was inverse tangent of 72 over 75 minus angle y from the small right triangle, which is inverse tangent of 12 over 75. I'm going to put this into my calculator and I'm going to round to the nearest tenth, and that will give me the value of the angle I'm looking for. So I'm typing in second tangent, 72 over 75, minus second tangent to get inverse tangent, 12 over 75. And I got that angle theta is approximately 34.7 degrees. Okay, moving on to the next one. So a person measures an angle of depression from the top of the wall to the ground. Remember that angle of depression is always outside the right triangle because it's the angle at which, if you were standing on top of the wall and looking down at the ground, it's the angle at which you would be looking down at the ground at. And that's a 52-degree angle. Remember that the angle of depression and the angle of elevation are alternate interior angles, so they are congruent to each other because the sky and the full ground are parallel to each other. So now we have an angle inside our right triangle. We're looking for how high the wall is and the point on the ground. So the point on the ground that the person's looking down at was 62 feet from the base, from the bottom of the wall. So that's right here, from the base of the building to the point on the ground. Base of the wall, I should say, to the point on the ground. So from our focus angle, we have opposite and adjacent, so that's going to be tangent. So tangent of the 52-degree angle is equal to opposite over adjacent. We're solving for a side, so we're going to cross multiply. 62 tangent of 52 is equal to x. We're rounding to the nearest tenth. I'm going to type this into my calculator, 62 tangent of 52. And the height of the wall is approximately 79.4 feet. There we go. Okay, moving along to the next question. So here we are looking for the distance from C to D. And keep in mind, CD is the side of a non-right triangle. So you can't just set up a trig ratio to find it because that's not a right triangle. So just like in the one with the angles, we're going to have to use the right triangles that we have here in order to find what we're looking for. We do have this small right triangle over here. And using the small right triangle, we can find CB. We also have this big right triangle, and using the big right triangle, we can find DB. And if we have both of those and we subtract them, we'll get what we're looking for, which is CD. So yellow minus red will give us black. I'm going to call this X so we can refer to it. I'm going to call this Y so we can refer to it. I'm going to start off with the big right triangle, just like I did when we were doing the angle one. And from the big right triangle, we have our focus angle is 31 degrees. We're looking for opposite, and we have adjacent. So that would be tangent of the 31-degree angle is equal to opposite, which I labeled as X from the big triangle, over adjacent. Since we're solving for a side, we can cross multiply. And once again, if you put this into your calculator now, please leave 3 or 4 decimal places until your very last step. Otherwise, you could potentially be rounding early. Okay, now let's go to our small right triangle. And from our small right triangle, our focus angle is the 15-degree angle. We're looking for opposite for Y, and we have adjacent. So once again, that's going to be tangent. The 15-degree angle is in the small right triangle. Opposite I labeled as Y, and adjacent is 3,280. Once again, I'm solving for a side, so I can cross multiply. And now that I have X and Y, I can subtract them to find CD. So CD is equal to X minus Y. So it's equal to 3280 tangent 31 minus 3280 tangent 15. I'm going to type this into my calculator, and since this is my final answer, the distance between C and D, I am going to round according to the question, which is to the nearest foot, which means the nearest whole number. And CD is approximately 1,092 feet, rounding to the nearest whole number. Okay, this one over here, Alex and Marlene are both correct. In your explanation, you do need to explain why they're both correct. So there's two possibilities. You can find the last angle here, which would be 90 plus 28, which is 118 subtracted from 180. So this angle would be 62 degrees. And you can explain that sine of the 28-degree angle is opposite over hypotenuse, which is hj over 20, and that cosine of the 62-degree angle is adjacent over hypotenuse, which from this angle would be hj over 20. So they are both correct. Another way that you can explain it is by using cofunctions, because 62 and 28 make 90 degrees, and sine and cosine are cofunctions, which means that they're going to be equal to each other when their angles are complementary. So I'm going to write that here. Since sine and cosine are cofunctions, they are equal when their angles are complementary. Since 62 plus 28 is equal to 90, sine and cosine will have the same ratios with these angles. And make sure to answer the question. Both are correct. Once again, this is only one way to explain it. You could have also explained why each trig ratio is correctly set up, opposite over hypotenuse, adjacent over hypotenuse. And finally, for the extra credit, I'm not going to go through the whole thing, but to prove something's a rhombus, you first need to prove that it is a parallelogram. And then to prove it's not a square, after you show it's a parallelogram and a rhombus, you can show it's not also a rectangle. Actually, I am going to do this one because it does come up on the Regents exam quite often. Let me graph real quick. So first, I'm going to show this is a parallelogram. And the way that I'm going to do that is I'm just going to find the slopes of the opposite sides. And you can do that either with slope formula for MA and TH, and for AT and MH. It does need to be for all four sides, but I'm going to just use rise over run so I can use the grid. So these are negative slopes, so because they're decreasing lines. And rise over run is 1, 2, 3, 4. 1, 2, 3. So the slope of MA, let me write here, slope of MA equals to negative 4 over 3. If I count here, 1, 2, 3, 4, 1, 2, 3. The slope of TH is also negative 4 over 3. The slope of the other two opposite sides, the slope of AT, is 0, it's a horizontal line, and the slope of MH is also 0, it's a horizontal line. So since both pairs of opposite sides are parallel, quadrilateral math is a parallelogram. This also shows that it's not a rectangle, which would make it not a square. So I'm going to write that here. Math is not a rectangle because no consecutive sides have opposite reciprocal slopes. So they are not perpendicular, and there are no right angles. So it's not a rectangle because there's no right angles. If there were, we would have to have some opposite reciprocal slopes. So the last thing that we need to do is to show that it's a rhombus. So I showed that it can't be a square because it's not a rectangle. And first it had to start off as a parallelogram, but I also have to show it is a rhombus. So the property of rhombuses that I'm going to show, so if you like distance formula, you can show that consecutive sides are congruent. I prefer slope formulas, so I'm going to show that diagonals are perpendicular, AH and MT. So formula for that, so slope of diagonal AH, so that's going to be y2 minus y1 over x2 minus x1, and that's negative 4 over 8, which reduces to negative 1/2. And I'm also going to find the slope of the other diagonal, MT, and that's going to be y2 minus y1 over x2 minus x1, which is 4 over 2, which reduces to 2. And another way of writing 2 is 2 over 1. And as you can see, these are opposite reciprocals of each other. So I'm going to write here, since AH and MT have opposite reciprocal slopes, they are perpendicular. So quadrilateral math is a rhombus. Once again, having perpendicular diagonals makes it a rhombus. And then you can end by saying, since quadrilateral math is a rhombus but not a rectangle, it is not a square.